Hey there. Guess what I'm doing, or have been doing? Yes, working on my program, and I added a great new organizational feature, which is like a little control panel called Control Panel, and it sits on the bottom there. And this it's good because it allows me to sort of compartmentalize certain options, and I have more space on the screen. This here is indicated here. You'll notice that it started me up immediately in edit mode, so that's good. You don't have to switch. I don't even know what the other mode is for, but I have one thing I use it for is to refresh when things go wrong. So I like having the ability to switch away and back to something, anything. Um, and So now the kinds of options that I want available are kind of like mode switcheroos. Like for instance, if I'm in the polygon mode, okay, on path, not polygon. In the polygon mode, okay, and right now this is set to medium thickness line. First, you'll notice that this indicates the position or not if I have this checked. So that's something that I can turn on or off on the fly. And knowing those positions can be useful if you want to double check, even if you've made a mistake or something. I'm not being very careful about making sure that it's going to fit, but that's okay. They don't stay in the end. Once I'm done this polygon, they'll disappear. Okay, now that's a polygon, but it's not filled. So for instance, if I try to grab it in the middle here, it won't grab. I have to go almost, hey, should be able to grab, oh, there it goes. But yeah, in the middle, no, but near the edges, seems like there's something wrong with this edge. Okay, well that's probably because I have my formula wrong. Outside it says. Now it was almost exactly, now it's working. There are some kind of weird bugs that seem to have to do with initialization problems. And now it's working perfectly. But when I did it here, it seems to die. Yeah, see that? Now it's retained something about me clicking in the middle here. Now, what it could have possibly retained, I don't know. It could be if I just click somewhere. No. Now I got it and it's going to be working. No. There could be something about that point there. I should still be able to grab this thing. I don't know. Anyway, but if it's a filled polygon, oops, I can delete that because I can grab it. We can go to polygon mode. then I should be able to grab it in the middle. So I'm doing a calculation to try to work out if the point is inside the polygon. There is, I think, a built-in function, but I want to actually work that one out because that's an interesting problem. This has to do with something called the winding number, and like for instance, this one is called convex, but something like this is not convex, and I'm going to have problems in this one of these regions. This region I might have problems everywhere. See, the way I determine or try to determine inside is by trying to find out for a given point. Say I click here, right? When I clicked there, I walk through all these lines and see if the point where I clicked is to the left or to the right, okay? And if it's a convex polygon, then whether it's left or right will be the same for every single line. If I'm going counterclockwise or clockwise, if I click here, if I'm going clockwise, it's to the right of this line, it's to the right of this line, right, right, and right, right, right? Or if I'm going this way, it's left, 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 and so on. So as long as the sign remains the same, I claim, therefore it's inside. Now with a thing like this, that's not going to be true anymore. Left, right, right, right. It's to the right of this line, but it's to the left of this line. And it's to the right of this line, right. The rest of them are right, right? However, there's a theorem about determining whether something is inside or outside of a solid object, something that doesn't have holes. And I don't remember exactly the way it works, but I think that if suppose I'm checking this line against a click here, it seems pretty obvious to me that the line from any point along here to that point crosses a boundary twice, right? And it's to the right. On this line, on this line, it's to the wrong side. It's to a different side, and it crosses one boundary. So it could be that, now what about here? It can only cross, for this line, it can either cross no boundaries and be on the right, or two boundaries and be on the right. For this line, it's on the left and crosses one boundary. See what I'm saying? So the leftness plus boundary seems to add up to let's suppose left is negative and crossing a boundary is positive, then we get 0, 1, Not in this case, we would get 2. I'm thinking that the algorithm could be that inside is if I'm going clockwise, the for a for a convex region, everything should be on the right. Okay, and if it is on the right, and crosses 2 boundaries, then that's still okay. However, if I find it on the left, but crossing only 1 boundary, then that's okay. If you see what I mean. Actually, I wouldn't care about the boundary when it's on the correct side. If it's on the incorrect side, then it must cross 1 boundary, and therefore it has to be inside. You see what I'm saying? That makes sense to me. If it's on the wrong side, the only way for it to be inside is for it to have crossed exactly 1 boundary. Suppose I make something where it crosses. Let's see if we can construct a scenario where it's inside, crosses 2 boundaries, and is on the wrong side. Let's get rid of these. Let's see now. I want it to cross several boundaries. Alright, there's a weirdo shape. If I'm going clockwise around, let's consider a point here. Here it's on the wrong side and crosses 1 boundary, and that's okay because it's on the wrong side. It has to cross the boundary to get back in. Here it's correctly on the right. Here it's correctly on the right. Here it's on the wrong side, but it crosses 1 boundary and 1 only. Here it's on the correct side, so it's okay. Correct side. Here it's hard to tell because it would be on the correct side as that appears actually. Correct side. Here, well, it depends on how far up. If it's this far up, it's going to be on the correct side. If it's here, if I'd drawn this further down, let's say this went further down and it was here on the left side, then it would cross this boundary once. I want to construct that scenario. Let's clear that. I think those will clear away. I just made nothing. Well, let me get out of this mode. I don't know, I can even grab this one. Come on, there's gotta be one spot somewhere in the middle. I don't have. Oh, I see, it's still working on this one. Come on. Get out of this mode. Now, see, I'm messed up. I can't delete it. The only way is to use the delete all, which I removed the key shortcut for it because that seems to get things out of sync. All right, let's try it again. Now I need something that has a big thing like that. Something where it might cross boundaries here. Okay. Here, let's consider a point here. If we just say that being on the right is okay, I would say that's not a good rule for this line because it could be in this region, right? Let's see now. I think it has to okay with every segment. So if we had a point here, it would be on the correct side, but not crossing two boundaries, so it would be outside. And that's right. Here, it would cross two boundaries. If it's here, if I'm checking from this point, and the point is here, it's inside and on the right, so therefore it has to cross an even number of boundaries to be inside. 1, 2, 3, 4. See, it seems to work. If I go here, can I make it 3? Is it possible? How about here? No, that's 2. Now, if it's here, and I'm going on this line, it's on the wrong side, but only crosses one boundary. These are even. Here, it's, what is it, on the right or the wrong side? I think that if I'm moving this way, it's not on the right, it's on the left of this line, definitely, right? So more than 180 degrees that's left. 1, and that crosses 3 lines, and it still agrees with the rule. So I think I can work out a rule that way, and if I want to check if something's inside, I need to be able to determine how many lines something crosses, and so it's important for me to figure out this whole business of intersecting lines. The points where lines intersect. So one of the things I added to the line, I added 2 things to the line drawing mode. Let me get full screen. Line drawing, previously it was just this. And you'd get a big long line, right? And if I wanted to draw just a short line, I would go into the polygon mode and start drawing a polygon and then switch back to another mode. But so instead, now that I have this control panel, I can add flags and things that I can turn on and off, and the various modes can check with the control panel to see what they should do. So if I click this one, now the control panel, if asked, will say to draw bounded lines. So if I draw one point and another, it's bounded. I can still change colors. Now, one of the things that I was curious, I always had trouble with was these right angles. Well, like closest point on a line to a line. I was trying to do this by hand. Look at the mess I made. Oh dear. You see how long this is? Well, it's actually instant to do all this stuff on with the other, when I'm logged on as the other user. This user is very slow. Now I kept making mistakes, and first I ended up, here are the points, P0, P1, and R, right? And I'm trying to find capital R. Well, first I computed it, I guessed it was probably around here. And then I went and computed it and made a mistake, and that said that it was supposed to be here. And I thought, that doesn't look right, right? It shouldn't, that's not where it should be, right? It doesn't look like a right angle. So then I hacked in quickly something to draw a right angle, or just draw a straight line that I can rotate until it looks like a right angle. And I drew this like with this function, y equals x at different angles. And then I rotated that by 90 degrees. So I lined one up, this yellow one here. I don't know why I changed it to green. And that looked parallel. And that was 35 degrees. And then I added 90 degrees to make it 125. And then I slowly moved it towards where it should have been. And the answer that I found, in the end, I came up with was pretty close, but off still by 60%, or 6%. But now with the new line mode thing, I have another thing called right angle line mode. And what that does is turn it on. It's going to be difficult. I can do it in here. I need a different color. Okay, we'll go from here. Oh, it's already got a last line. Let's start again. Should have forgotten that. Now I hope I've drawn a line. I see some green there. I can change colors on the fly. Now if I just click here, it should do a right angle. See? And the answer there, minus 2870, is in fact not this one, but what you really do get. This number is wrong. It's less than that. So yeah. So now the way that I clear the screen, because I don't have that thing, I just have an empty one. Open up. And you'll notice that I've changed this. See, one of the problems I have with using this tool is that I don't realize that I'm in a dangerous mode, and a click might cause something to happen. So when I'm actually in an active mode, this is red, and when I'm in an inactive mode, safe mode, like I want to draw some text, it's green. So I'm starting to notice this color, and that's good. Alright, so now how about this? How does this work? I'll go to line mode. I don't think, no, there's nothing in here anyway. Bounded or not, the next click is going to find a point on this line segment, even if it's beyond the segment. and draw a right angle line. And I can change the color maybe in the middle I prefer to. So if I click here, it's gonna draw it. There it is, but it happens to be outside of the segment. But if I continue the segment, this would be right. This is right angle to this. Now that could be useful if I wanted to draw a right triangle, for instance. The bane of my existence. I should really keep the points because I want to see the numbers actually. Those things I can delete individually just now because I added an ability, the ability to delete things that are not things I can pick up. But the things I can pick up are these one type of thing, and the things I can't pick up, cannot pick up, are things like a sine function. If I make a sine function, I don't have an interface for picking it up. Right. Although it's well suited to picking up, it can rotate and move and everything, but as yet I don't have a function that will tell me if I'm near a line, near a function. Right? Now there's a way to do that too. That's quick. You could go through every single point and check, right? But it turns out that if you want to find out the distance from a function to a point, any function, let's try and take something weirdo looking. Well, I can use the I put in the spline thing and normalize it. It's much smoother now that it's normalized. And that's this mode. I don't know, color. Now see, it didn't take that color. There's something wrong with the color initialization. And also, sometimes it gets in a weirdo state where everything has loops. But now it's okay. You see, that's fairly smooth. Now imagine there's a point, and I tried this. It took me all night, and I finally managed to do it. I mean, make a visual demonstration of it, but I deleted it. Imagine we have a point. Now, I don't really have a point. I have this same mode that we're in right now, but it'll show me the coordinate. Now, see, it did it again. It's one off in the color. Just like a straight line, okay, wherever the closest point is on this curve to this point, the tangent is going to be perpendicular to this point. So let's suppose this is the closest point, okay? Now I'd like to be in the line mode. Hopefully it hasn't remembered something. If I go, let's say it's here. I'm gonna try and draw a tangent. I want not bounded. Okay. Now the next point I click is going to be perpendicular. Okay. it turns out that the tangent to a curve at the point of where it is closest to another point will be perpendicular to the line connecting the point and the curve. This point. Okay. Now the reason for that should be fairly obvious. Because am I still in the line? No, I am. What's it gonna do? I just drew a thing. Can I get out of this? I'd like to draw another tangent. Well, I can draw it along this one. Yeah, great. Change color. It's still going to make a perpendicular to that. Okay. Let's suppose we draw a tangent here in blue, using the like delta y by delta x, right? For a small range, I'll get a line, a slanty line like that. If you imagine something moving along, now I want to be in the vector mode. Blue, white. Imagine some little ball or something is moving at this point here. That means their velocity is like that along the tangent, right? Now consider the line that connects. Now I want to be in the line mode. No right angle stuff. Not different. White. Here's the point on the graph, and here's my point, right? Actually, I was okay. So now that's the point connecting the point. Forget about these other lines. Just the point connecting the curve and the point I'm interested in. If you take the dot product of this velocity, okay, with any vector, let's say a unit vector in the direction of the point, right? Then that's going to give you. Now I do want perpendicular. I want to drop a perpendicular. I can. It's approximately right. Okay, we'll try it. It should drop it. Okay, so therefore there is a component of velocity towards the point, right? Here, this component here I implemented one LaTeX command, which is so useful. Right? V velocity along, I don't know, I'm going to call it AB, and I'll put the letters in a minute. Oh, I didn't want to delete that. Oh well. I have an option to not have it clear out the last. So this here, and I can even draw a circle around it. Just handy for these kinds of demos. Almost. Okay, this here component is of this velocity is always made up of two perpendicular components, no matter what set of axes you choose. And I've chosen the set of axes to this point here that I accidentally deleted. And there's a component of velocity towards this point, right? And if there's a component of velocity towards this point, then that means that as time increases, this position is getting closer to this point, right? Because it's moving towards it. Similarly, it might be moving away. It's certainly not singular in being the closest or furthest away, right? The closest point will have to be a point where there's no component of velocity towards the point, a stationary point, and in fact it would have to be one in which the component of velocity changed from one direction to another, from towards to away. In fact, I think it has to be that. Or maybe from towards to none, could be. Like if it goes into a circle or something, right? If at this point it just went into a circle where all the distances were the same, that would be one of the closest points. At this point, what would I want to do? I guess a vector. I was using white, but there's too much white there. I don't know if the vectors are on top. Oh no, not that color. Green. The point on this curve is moving along this white line that we computed. That's the velocity, right? And the perpendicular to that line is perpendicular to the velocity, so there's no component of velocity towards the point. So therefore, it's in terms of the distance to the point is not changing at this position on the line, and that's since that's a stationary point, it's a candidate for the closest point on this curve to this line. Now there are only a few candidates for a curve like this. Nothing here, this one, and maybe somewhere else you might find one or two other positions that you have to check. So you don't have to go through to find these points. Is quite easy. What you want to avoid is having to calculate the distance at every position, right? But calculating the velocity vector at every position is easy. You just subtract two numbers and that gives you a vector, right? And take the dot product with the position, and if that's non-zero, then you can just keep going until you find one that's zero or close within some range near zero, and that would be a candidate. You might never find one. Well, it's hard to say. You see, as a point passes, just like with a straight line, if I have a point here and I have another point that's moving along a straight line. As it passes, as it's moved, as it's if it's over here, I'm moving. The same argument applies, right? I take a line connecting my position with the point. Darn it. No, I found it. No right angle. Okay, that's it. The position. Now, oh, I do want the right angle. Well, it'll work. Actually, it'll work. Here's my velocity. I click my velocity, and there's a component. There's a component towards the point. So therefore, I'm not at the nearest point. However, when I'm at this point, line again. I'll try to make this easy. Now, I don't have to be exactly there. I can go a little bit past and then click here. So suppose like that. And I'm going to click here. At this point, my velocity is still this, right? And here's the line connecting me and the point. And there's no component of velocity in that direction. So therefore, that's the closest point on a straight line to this point. Because as I'm further down here, right? Now here's my connecting line. Right? And therefore there's a component, I have a component of velocity. If I take the dot product, there's going to be a component in the negative direction, right? Along here. My component is an away component. It's I just drew that line, didn't I? So if I just click here, there, see? So this here is my component of velocity along the line connecting my position and that dot. It's away, but it's non-zero, and so therefore I'm not at the closest point. I'm moving away. And that's how you can tell in computer graphics or computer game theory. You have an object, okay? Let's say you're doing vector graphics. So that means you have a bunch of polygons unfilled. Or maybe circles or something. And these are objects moving around in your little universe. Okay, now if I want to know if this object is moving towards this object, right, what you do is you can choose one or the other, but it's easiest to change your frame of reference to be inside the frame of reference of one of these moving objects, okay? But you could also do it without changing any frames of reference. Suppose you take your position as being the center point, okay? What am I in? Line mode? Path. No, I don't want path. I want line. Okay. Now you now compute the distance vector, from you, the position vector between you and that other object. If you're in the frame of reference of this thing and stationary, then you can recompute this thing's velocity vector, okay, and that's going to be in some direction. Now what have I got here? Right angle mode. Well, I'm going to go to vector anyway. This object may, even though it might be moving this way, relative to you, its velocity might be something like this. Okay? If that's true, then it's moving towards you. Go back to line mode. It should remember actually. Okay. So now if you take the dot product of the relative velocity vector and a unit vector connecting the two center points, and if that dot product is negative, then the object is moving towards you. This object is moving towards this object, otherwise it's moving away. And that will save you during the collision part, because after the collision occurs, the velocity will change sign, right? But all these things are moving, right? It's relative velocity that you care about, and you don't want to keep colliding and colliding because the thing's intersecting with you. You have to be able to check and see that it's moving away. So once this object comes and collides with you, right? And then your position might be here. The center positions like that. After the collision, you reset it, you tell it to move away, and the next frame comes along and you find that you're still in contact with this object. You take the position difference, right, and compute its velocity, relative velocity, and that might be a vector like this. I don't know. Okay. Now I'll go back to the line mode. You see why I wanted this perpendicular thing. Now I click here. Okay. And so therefore the component of velocity, relative velocity of this object with respect to you is this vector, right? Because this plus this gives this. This is its actual velocity. This is its velocity in the direction of you, and so therefore it has another component this way. So they add up. So this thing is in contact you, but it's moving away, so you don't re-collide with it. It's already collided. You don't have to maintain a Boolean with every single object, whether or not it's collided with you. And that's important and simplifies things greatly. And all you have to do all you do is you take this vector and this velocity vector and just take the dot product uh, of the two vectors, and if it's plus, it's moving away, and if it's minus, it's moving towards. And that's a two, like one line calculation, right? Nothing complicated. Doesn't matter if both of them are moving in weird ways and whatnot. It's a very simple thing. So you've learned a little bit about vector graphics. And by the way, I started another channel where I'm going to do some more of this mathy stuff on there, and maybe I'll post a link at some point. If anyone's interested in linear algebra, I'm going to show how the nearest point algorithm works. Mine isn't exactly the same as that other one, but all I want to do is try to make sure that to avoid having to take a square root, having to use the square root function, because that's expensive and you don't have to. You only need to be able to multiply numbers. Here, to get distances, I need to use the square root function. Okay, well, I hope you enjoyed that. I don't know what other features I have to show you. You saw this polygons, right angle mode, the coordinates. There's a lot more stuff under the scenes that you don't see. For instance, these files, like if I save this, not there, I want to save that, I want to keep that. It should have some. I want to be able to say binary binary data, for instance, for fonts, right? There's more to a font than just the color. It might be dash dot, or it might be hollow, or whatever. But there's one structure that completely describes a font: bold and not bold, the style, the color, the thickness, and so on. And it's a structure, but it has zeros in it. So I went back, and oh yeah, there's lots of them. And I had the decode for the something 64, int 64 text encoding for binary data, and I used that. I had the decode, I had to write the encode, so now it can do both. So these ones, I only use it in one place. So these are log font structures. As you can see, this one is mostly zeros, and this is all zeros, mostly zero. This one's bigger. I do log brush too. So this could be a log brush. It can't be this one because this is obviously smaller, right? They're fixed size, and the algorithm is not a compression algorithm. So one of these is a log font, and one of these is a log pen. And from those you can get the color and style and all that stuff is stored in there. Okay, see you.